Hi everyone, I am Melike Feyza Bahadırlı. I am second year CS student at Bilkent University and this is my Physics 101 project. In this project, it is aimed to calculate spring constant by using the energy conservation law. The principle is based on the conversion of elastic potential energy to kinetic energy. The experiment is divided into 4 parts. And for 3 parts of the experiment, the air table is used to conduct the experiment. The puck is placed in front of the spring and compressed the spring. We observe the motion of the puck. To calculate the elastic potential energy, kinetic energy of the puck is needed to be calculated as I mentioned. So in the experiment, the velocity of the puck is calculated and the kinetic energy is calculated, and using the equation, spring constant is obtained. In the first part of the experiment, data are obtained by using different compression legs. Also, inclination is given to the air table by placing a block under the air table, and then a ruler is used to measure the compression legs. The compression legs are 1, 2, 3, 4 and 5 cm. After compressing the spring, the puck makes the projectile motion with horizontal velocity, which was given by the spring since it is compressed. This is 1 cm trial, and then let's again the 30 cm. 1, 2, 3. The distance is calculated between the compression points and the dots on the paper, and the velocity is found. So the spring constant is calculated, and the obtained data are here. In the second part of the experiment, again inclination of the air table is used, and the puck again makes the same motion with the first part of the experiment. In this part, the data are obtained by using different total masses. To be able to change the total mass of the puck, the additional masses are used and they are placed on the puck. The total mass is calculated by adding the value of the puck mass and the additional mass. For that, 100 gram, 200 gram and 400 gram masses are used to change the total mass. 200 gram, and then again compressing the 2 centimeter, and compressed spring 2 centimeter for each trial. The spring constant is calculated with the same procedure of the first part of the experiment by using the same equation. The increase in the distance between the points indicates the increase in the velocity, and the obtained data are here. In the third part of the experiment, the inclination of the air table is not used, and the experiment is repeated with the same procedure in the first and second part of the experiment. Again, the different compression legs and different masses are used to obtain the data. Since the inclination is not used, the puck goes in a straight line. Compress the string 4 cm. After measuring the distance between successive points, the velocity is calculated and the spring constant is found by using the same equation. And then with different masses, I use 100 gram and then compress it to 2 centimeter. Decrease the mass and then again compress the The obtained data are nearly consistent with the other parts in the experiment, since as we know that the horizontal velocity doesn't change in the projectile motion, so the inclination of the air table doesn't change the results that are found in the other parts. So it is shown that the inclination can be any values when we are conducting the experiment. In the last part of the experiment, the hook law is used to find the expected spring constant by hanging 100 gram from the spring. The extension leg is found as 1 cm, and the value of the spring constant is calculated as 98. The error rates are here. These errors can be caused from some factors. For example, in the experiment, I couldn't really compress the spring for exit value. Also, when I compressed and realized spring, I could give some initial velocity to the puck. This could affect the found results. Also, in the second part, for some trials, since the mass is not distributed equally, the puck makes a little bit of rotation around itself. In the first part of the experiment, the error rate increases 4 cm and 5 cm trials, since more force is applied by the spring and it is hard to maintain the state of the spring in this position. And also there is a friction between the air table and the puck, even if the air table reduces the friction in the lower rates. So all of them affect the calculation and cause the error rates that are shown. Thank you for watching.